Our upcoming DevOps expert is the CEO of Chaos Native, apart from being a regular speaker on the captivating subject of chaos engineering and cloud native DevOps at various conferences. He is also a maintainer of CNCF Chaos Engineering project Litmus. Besides his passion of building solutions around resilience through chaos testing in cloud native space, our expert is a regular speaker in events, meetups, and conferences related to SREs, reliability, and chaos engineering. On his session today in the DOS, he will share his in-depth insights on the typical challenges of scale and reliability in cloud native space. He'll also touch upon the role of developers and the best practices in increasing the resilience of the application that they build. This talk will cover the basic architecture and use cases of Litmus Chaos. Adding his sparkling vibes in the DOS house today, please join me in welcoming Mr. Umasankar Mukkara. Over to you.
Everyone, welcome to DevOps India Summit 2021. I am Uma Mukkara. I'll be talking today about chaos-enabled DevOps and how and what you can use chaos engineering in the chaos-enabled DevOps. About me, I am a co-creator and maintainer of Litmus Chaos project, which is the CNCF sandbox project. And I'm also the CEO of Chaos Native, which is the company behind Litmus project. And we also sponsor the support services around Litmus for enterprise users. And we do provide services around reliability engineering for cloud native ecosystems. So today, I'm going to talk about chaos engineering for DevOps in cloud native. It's important to understand what has changed in cloud native DevOps before we go into chaos engineering for cloud native DevOps, right? So cloud native itself is a transformation of IT that was started a few years ago. Now it has crossed chasm. It has got mainstream adoption, and most of the ecosystem around IT is either thinking of adopting Kubernetes or has already adopted Kubernetes or in the process of adopting it, right? So while that's already going on, there are still adoption challenges when it comes to reliability, right? Reliability, how will my services be after I move to cloud native or Kubernetes or microservices architecture? And this reliability is really a challenge because of two things, the two fundamental changes that are happening in the move to cloud native DevOps. One is too many microservices. Your application is being broken into multiple microservices, and they come much faster into, the changes are happening much faster, right? And they can run anywhere. The fundamental assumption around containerization is you build once and run everywhere or anywhere, right? So your application, there are too many microservices and they're coming faster and they run in many places than earlier that they're used to. So to summarize the reliability change, earlier you build it, you ship it, and you run it. That's what legacy DevOps is. But in cloud native DevOps, you build, you ship them 10 times faster, and you're running them in 1,000 different scenarios. So your code runs in many different places, many different underlying infrastructures, either cloud platforms, on-prem systems, etc. So fundamentally, there is a chance that your code is being exposed to 1,000 more times varying environments, which really means that the faults that can happen in these environments will affect the way your code responds to that failure. So that is the question around how reliable is my code or my service is in the new cloud native DevOps, right? So that's fundamentally the challenge that we are talking about when it comes to reliability in cloud native DevOps, right? If you see the cloud native DevOps, it's shipping fast, it's dealing with microservices. The CI/CD for microservices has been pretty good. There are many tools available, many improved tools that are available right now to deal with this proliferation of microservices for CI/CD. And on top of that, there is an evolved architecture around GitOps. So the configuration for this increased microservices can be well handled at scale using GitOps, right? So at the same time, to take care of reliability for this increased number of microservices in cloud native DevOps, chaos engineering is on the rise as a way to approach to tackle reliability. So CNCF has announced some of the survey results last year, end of last year, where chaos engineering was seen as the top trending technology in terms of technology adoption in 2021. And we're seeing more trends being observed in big conferences like KubeCon and other surveys, where chaos engineering is being pursued as a way to handle the reliability challenge, right? And chaos engineering itself is on the rise with so many new tools coming and so many architectures being evolved and so many vendors coming into the place. And I'm going to talk a little bit more about Litmus in this session, but chaos engineering is out there now in a better available form for DevOps, for cloud native, right? So what does it mean, chaos-enabled DevOps? What does it mean, right? So it's cloud native DevOps. That means you're basically handling development and running the operations of cloud native services, but you're going to consider chaos engineering at all stages of this DevOps, right? So it's not just the traditional chaos engineering for ops, it's also for dev and QA in chaos-enabled DevOps, right? And why and how is what I will talk about. But basically, in chaos-enabled DevOps, you are seeing all personas of DevOps, including the management, looking at chaos engineering as a way to handle reliability, right? So it's well known that SREs and operations teams have seen chaos engineering as a way to achieve better reliability, but the modern CI/CD sees QA, especially in their user acceptance tests and all, because there are more microservices being available. You would like to go and chaos test them and verify quality of the services being shipped with respect to failures, right? And similarly, developers are also increasingly looking at chaos testing their code before they're being shipped out. And for management persona, it's very important to see chaos engineering from the observability perspective, primarily either in large QA systems or in the operations itself, right? So how is my system doing with respect to the faults that are being pushed by design, right? So in terms of operations, what you will typically look for when you adopt chaos engineering, it is supposed to increase mean time to failure and reduce the recovery rates, MTTR, right? And this is generally achieved by identifying this parameter and measuring them. The parameter is MTTI, mean time to inject or mean time to identify, right? So what this really means is that as an SRE team, you should be able to inject the fault at will very quickly, right? There may be complex scenario that may come up, and that complex scenario can mean injecting 2-3 faults in a sequence or in parallel on different systems. So how do you put together this fault and see if my system can sustain this fault or not, right? So that's mean time to identify a fault or inject a fault, right? So that's very, very important. And that's what chaos engineering, a well-designed chaos engineering practice can help SREs to go and inject a fault at will. So overall, these metrics, they will start improving over a period of time. You start with reducing MTTI and start reducing MTTR. And over a period of time, your time between the failures will increase. And then that's what you want, less outages, right? So, and also one more parameter to look for in the reliability metrics around DevOps is SLO management, right? So what is your service level objective metric, and how are you defining your SLIs? And how are they being managed against these failures, either in pre-production or production, right? So as long as we are sticking to identify these metrics and measuring them and then working around them, you will have a well-engineered chaos engineering practice, and that'll start giving some results very quickly. But over a period of time, it's going to give increased speed in terms of the result, right? So that's really chaos for ops. So when it comes to chaos for QA and dev, it's really about adding chaos or negative testing to your existing practices, right? As QA, you are doing failure testing in your DevOps cycle, and you need to add chaos testing as a separate stage. That's really because you are going to see multiple microservices that are providing support to your actual code. So you need to be able to do a much higher level of failure testing called chaos testing, right? So that's what is needed in user acceptance testing, put in or throw in chaos testing, right? And for developers, earlier in the legacy DevOps, it's plain and simple. Write my code, write unit tests, and you have some interfaces to test, and then you're good. And you raise a PR, it gets tested, and then it gets merged, and it goes to QA, right? Or the next level of testing. But in modern day DevOps or cloud native DevOps, you have microservices that can cause more dependency. A failure in these microservices can cause failure in your own testing, in your code, and you can test that right in your build time, right? So you don't need to wait for QA to come back and see that, hey, your code is not working well when a dependent underlying microservice faulted in some fashion, right? Or possibly an infrastructure failure was not taken care by your code. So it's possible to do all those chaos testing right at the time of building your code or even before merging the code. So this is a possibility now with the modern day chaos engineering tools, right? So my recommendation is that dev teams and QA teams should look for adopting chaos engineering as a way to increase reliability much earlier than what ops can do, right? So to summarize, chaos engineering in modern day DevOps is for everyone. Increase operational efficiency, improve overall efficiency in your CI/CD pipelines, and also your KPIs in QA can be increased by adopting chaos testing, right? So that's a quick summary of what is chaos engineering for modern day DevOps or cloud native DevOps is. And this change is happening already, right? So chaos engineering has been mostly for SREs till now or a year ago, but we are already seeing QA teams picking up chaos engineering as a way to improve their quality metrics, and we will soon see more developers coming forward and looking at chaos testing their code at the build time. Right. So over a period of time, because of the sheer number of the developers, I foresee developers using chaos engineering more than either QA or SREs. Right. That's of course my prediction, and we need to wait for a couple of years to see what goes on. So now that we talked about chaos engineering, why and how, let's talk a little bit about a real tool that helps you do chaos engineering. So in this next few minutes, I'll talk about Litmus Chaos, which is a CNCF project sponsored, created originally by Chaos Native team. It basically supposed to enable reliability in a structured way in cloud native DevOps. So that's the real goal of Litmus Chaos. So we started really this project about 3.5 or almost 4 years ago now, and we announced publicly in May 2018 KubeCon. We just released 2.0 project. It's a major release where most of the architectural goals of Litmus Chaos have been implemented and well tested as well, right? And there are 1,000+ users that we know of various sizes, and there are tens of public references for this project. And it's seeing about 500+ installations in a day. That's pretty good for chaos engineering project like Litmus, right? And we are seeing a lot of adoption in the last 2 quarters, primarily driven by usage of Litmus in QA, I would say CI/CD, as well as the increased adoption of chaos engineering in the cloud native, right? So cloud native is also growing, and people are using chaos engineering in dev and QA, and that's probably the reason why we are seeing tremendous growth in Litmus project usage, right? So overall, Litmus project itself, if I need to describe, it's end-to-end chaos engineering platform that you can use to design, orchestrate, and analyze chaos engineering for either cloud native systems or even for legacy systems as well. So it's designed. I put 3 triangles here. So primarily what you have is in the middle, you have a Litmus Center installations where you connect some public chaos hubs and also your own private chaos hubs where you have your privately defined or designed, developed chaos experiments or tuned chaos experiments as a team. And you can deal with chaos central, chaos center or Litmus Center by a set of team members, because in reality chaos engineering is also a real deal where you do engineering of chaos experiments, right? So continuously tune them, develop them, enhance them, all that will happen. So that really means that there are a set of team members that will be managing these experiments. So you need to have a sense of manageability for chaos experiments, either they are SREs, developers, or IT managers. So all that will be structured around this Git repositories inside Chaos Hubs. And you can also use GitOps for automating via Git as a change to your application, or any event triggered injection of chaos is possible with the Litmus control plane, right? So what you do is you really go ahead and pick up your experiments and create a chaos workflow, and you target against either certain Kubernetes resources or certain cloud infrastructures or platform services, or basically VMs or bare metals. It can be anything, right? So it's well structured. You can start Litmus very, very small and then go beyond, your own that cluster, multi-cloud and hybrid cloud. All possibilities are there. You don't need to install Litmus again and again. You just need to install Litmus agents, right? So if I go and talk about a little bit more in detail, so you have a Litmus Center where teams can coordinate their experiments, as I just discussed. And typically what happens is you start creating, one of the users, they start creating chaos workflow. In this example, you have 3 experiments. One is about WordPress, a fault into WordPress application. The other one is about injecting some network latency, and also some error injection into your database. Right? So all these 3 things are happening one after another that you call a chaos workflow. And then you push this against a given target, right? And once you schedule it, it goes to your Litmus agent. and then which is on a given target. It need not be Kubernetes, it can be anything else, right? So it gets scheduled and it runs. Once the chaos experiments are run, whatever are there in that chaos workflow, you are going to get the results and metrics back onto Litmus Center, which is having Prometheus hooks to go and read the metrics and provide analytics in a good way to read what is the impact of my chaos onto a given application, or is the impact in terms of the chaos experiment success or failure, right? So we have identified a way to differentiate chaos control plane and chaos execution plane in a separated way, so that once you define these experiments, you can actually run them against different execution targets also, right? So these experiments should be reusable in most of the cases, right? So to summarize, the Litmus deployment model is something like this. You start with the Litmus Center, you onboard your users, and you connect to certain monitoring data sources such as Prometheus. Then you start creating chaos workflows and throw them against any of this type of Kubernetes clusters or non-Kubernetes platforms such as AWS, Azure, or you can even go after VMware or bare metal. And then you can have multiple chaos workflows on this, all gets reported, the results get reported back to the Litmus Center, where you have some nice reports and analytics. And that's primarily how Litmus works. And the crux of the entire thing is the chaos experiments and how you continue to nurture them to get better of fault injection mechanism in your environments. So how do you get started with Litmus? It's pretty simple. As I said, it's a Kubernetes app. You can start very, very small. And as you onboard more users, you can actually expand Litmus itself into a much bigger deployment, right? So you start with the Helm install of Litmus Chaos, right? And it gives you a Litmus Center where you log in, onboard the users, start chaos workflows, and then you run them. An example of a good chaos workflow that has some parallel and sequential chaos experiments are like this, good workflow browser, we call it. And you should be good to go from there. So how to get started with Litmus or chaos engineering using Litmus is through following links. You can go to our website, or Docs is a good place to run, and everything happens in GitHub. So there are multiple repositories in GitHub which you can get involved with. The primary repository is being Litmus itself, and there is a large, vibrant community which is a part of Kubernetes Slack. We are on a channel called Litmus. Inside Kubernetes Slack, you can join and get started by asking what are the clarifications that you need. So with that, I would like to conclude this session by saying that adopt chaos engineering as a way to increase reliability in a structured approach in your DevOps if you are moving to cloud native. So with that, I will conclude this session. Thank you very much for watching. I will be happy to answer any queries either here in this session or on, I'm available on Twitter, DMs are open. Thank you.